4.5 dealt with this equation. We sort of built up why the parts of it mean what they do. And of course, what does M stand for? Or, what's M represent? Slope. Did I tell you why they think it's M? They think it's comes from the French word marcher for walk, right? So like march. They're not sure about it though, so they're like, whatever. If you use the letter S, I would look like a 5 for me, so I'm glad they had M. It's fine. So that's slope. What's the B represent? The Y piece of the Y-intercept? So it'll be like 0, B. Woo. All right. Okay. So if I said state the slope in Y-intercept for what's wrong with that equation that's not letting me see what I should be able to see? Not in the right form. Exactly. If it's in this form, I can see the most important things about the line. That kind of kicks a lot of ass. If you had an equation that represented a circle and you put it in the right form, you'll see the center and the radius. Because those are the two most important parts of a circle. So how do I get this thing in the right form? Subtract 2x. Then divide by -3. Get out of there. Wow. By the way, real quick, some people are still doing this, and somehow that negative goes away too. That negative is still there, right? So then you get y equals. So what's the slope?
2 over 3.
Yeah, 2 over 3. Which means what?
You're going up 2.
Rise 2. Run 3. I love it. Kick ass. And what's the y-intercept? Zero, -5. There we go. Beat you guys into submission on that. It's got to be a point, and I'm trying to help you because you will make silly mistakes if you forget. There's 2 parts to that thing. Okay. Can you graph that, please? Look at that. I asked all nice and everything. Take a minute and graph that line using this information. All right.
Minus 12 was
So let's see. Where do I start?
It's not minus 12 -5.
0, -5. Cool. That's going to be the y-intercept, so it's where it hits the y-axis. All right, green. Going to work? Find out. And then I go up 2, over 3. I can do it again. Yeah, 1, 2. Over 3. I can almost do it again. There we go. So then I have a nice line. Make you big. Here. How can I check my work? Well, what point is this? What point is this?
3 -3.
3, -3. So if I put let's go to the original, a 3 and a negative 3 in, that's 6 minus 3 times negative 3. 6 plus 9 is 15. Check. Kick ass. I like it.
Can you say again for the check?
So you agree with me that that point is 3, negative 3.
Okay.
If my line goes through the point has to work in the equation. That's the relationship. So if I put that point into this equation, does it work? It has to if I've drawn that correctly. A line only goes through points that work in the equation, and the line and all the points that work in the equation are on the line. You guys with me? Okay. All right. Okay, so that's basically most of what we did last time, most of the first part of this packet. So let's look at let's do this. Do I need the Y-intercept to plot a line?
Yes. False. Of course.
Nope.
No?
You're going to prove it for me. Even though you disagree with me, some of you guys, you're still going to prove it somehow. So if I said I have a line that goes through, what you got, Jeff? Negative 2, 3, and has a slope of negative 1/3. Plot the line. You could do it. Plot that line. I could plot that line in 3 points. Try you, blue. Oh man. So, do you see how silly it is? Of course I don't need the Y-intercept to plot a line, do I? If I have any point, negative 2, 3. If I have any point and the slope, of course I can make a line. If it's the Y-intercept, that's a little better. That's kind of awesome because then I know what B is. So let's see. Slope is down 1 over 3. 1, 2, 3. Yeehaw. Can somebody tell me, does it look like B is a nice number? Is B a whole number? Doesn't look like it, does it? Right? Okay, I like it. So, how the hell do I get the equation of this line if B is funky? Yes? Stay with me now, stay with me. It almost doesn't matter if you're like, I wouldn't care about this in life. You care about this in this class, so get into this, you ready? There's gotta be a way to get the equation of this line. There has to. Even though B might be 2.48964, so I'm gonna have to forget about B. I'm just gonna have to go. There's got to be a way. There's got to be. So here it is. You ready? Does everybody understand the motivation behind what we're about to do? MX plus B is awesome. It gives me the Y-intercept, and if I know the Y-intercept, I can put it in there and get the equation. But do I always know the Y-intercept? No. Was I able to graph this line given this information? Yes, therefore I have to be able to get the equation of the line given this information. Because the equation and the graph are the same thing, just two different representations. You guys semi with me? A little tiny bit? Okay. Am I even seeing that? There it is, yay. All right, so here's the that's the motivation. Here's what we need to look at to start down this road. If I have, well, let's start here. What's the equation of the slope for 2 points, given 2 points? What's the equation for the slope? M equals what?
1.
All right, I understand. That might have been too vague of a question. You're like, what do you want from me? Rise or run? How's that? No, an equation. So this is the algebraic way to determine slope. All right. What do the little 2's and 1's mean again? Do you guys remember?
The second part of the Y-intercept minus the first part of the Y-intercept, and then the second part of the...
Careful now. There's no necessity of knowing any Y-intercepts. So I don't know if you mean Y-piece.
Y-piece.
How many points do I have? 2. So the 1's just mean those came from one point, and the other one means it came from the second point. You guys with me? Stay with me now. Stay with me. Come on. I really want this equation to make complete sense. Does it matter which 2 points I use? Let me show you this again. If I use 2 different points on any given line, would the slope be different?
No.
Because any given line, the slope can't change. If it does change, it ain't a line anymore. It's a curve. You guys with me? Okay, a little bit maybe. So, I don't have to, so let me see if you guys can get this. So this is if I'm given 2 points, I can then calculate the slope between them, right? So this is x1, y1, and this is x2, y2. So let me say this. I don't need any, if I'm given a point, does the other point have to be something specific? No. It could be anything. Anything on that line, any other point on the line. So the subscript, I tried to make a semi-big deal out of this last time. The subscripts always just mean a specific value for this thing. So x sub 1 means the x value from the first point. So if I take the subscript away, it's just any point on the line. It's not any specific point. It's any freaking point. You guys semi with me? Maybe? Okay. So that makes the equation become this. Which is, not ground shaking. But do you guys understand the concept behind that equation is, somebody gives me a point, what other point do I need? Any other point on the line, I can figure out the slope is. Is that cool? Is that all right? So, watch. Okay, let me put this up here. Oh yeah, I wanted to work on you. Let me not put this up here. See if you guys are cool with this.
I'm equal.
Hmm?
I'm equal 4 minus 4.
That's a y, right? Is that right?
Yes.
Okay. So here's what I'm going to do. I'm going to multiply both sides by x minus x1, because I don't like this big fraction. Is that all right? Well, I'm going to do that. Is it legal? Of course it is, as long as I do it to both sides. Right? So then we end up with this equation. So if I multiply this side, that goes away. I get y minus y1. M times x minus x1. Let me stop for a second. Is what I just did amazing? No. Can't I, any equation I have, can't I kill a fraction in it by multiplying by its bottom? That's all I just did. Is everybody cool with that? Do you see how this equation comes from this simple idea? So now look at how that's better than mx plus b. I'm going to be all over the place. Come over here. So I have mx plus b. To use this, I have to know the slope, and I have to know the y piece of the y-intercept, right? This equation, I need to know the slope. I always have to know the slope. That can't really change. But now I'm allowed to know any other point. It does not have to be the y-intercept. So for example, for this problem we just did, what would I put in for m? Well, negative 1/3, that's the slope. What do I put here for the x piece of the point? What's the x piece of the point? Negative 2. And what's the y piece of the point? 3. So if you guys are cool with, let me juxtapose that with a different kind of problem. In fact, we just did this kind of problem. So here's the idea. And I really want you guys, and again, remind me up here, what did x1, y1 mean? What did it mean over here? Versus x2, y2. What did x1, y1 mean? That was some points that I have, right? You guys with me? What did the m mean? The slope. And now I just changed it a little bit by saying it doesn't matter what other point I pick. It could be any point on the line. So we're going to make it a general x and a general y. So look, just by multiplying, it doesn't change anything. If I have any point, I put the x piece of the point here and the y piece there. If I have the slope, I put it there. Now real quick, just to show you the difference here. If I had a slope of 2/5 and a y-intercept of this, how could I use this equation? What would I put in place of m?
Slope is 2/5.
2/5, right?
So it's
2/5 x.
So y equals 2/5 x
Plus 7.
plus 7, right? Is that cool? You guys have zero problem with that. But all you're doing is identifying m and identifying b. So now I'm saying if the slope, so that would be the answer for that problem. If the slope was 2/5, but the point that I know
7.
is 1/7, do I know what b is? Do I know what b is? B is supposed to be what? The y piece of the y-intercept. How do I know I don't have the y-intercept? Because x is 1. Why was this the y-intercept? Not just because I said it was, but because x is 0. Cool. You with me? So when I teach this, people just suddenly start putting 7 in here, even though that's not the y-intercept. Right? B has got to be the y piece of the y-intercept. So is everybody cool with this problem right there?
Yes.
All right, so all I've done so far is say, oh shit, I don't have the y-intercept. I don't know what b is. So technically I can't use this equation then, can I? Thank God there's another equation for me that works for any point. So this is the point x1, y1. That's the 1x and the 1y that I know, right? x1, y1. So now you just, the same way that you're cool with just throwing shit in the right place, let me throw shit in the right place, right? So how's this go? Y minus the y piece equals m times x minus the x piece. What's the matter? You're shaking your head, you haven't done anything yet.
Understand what you mean. How are you gonna do first?
I don't understand. Are you cool with this equation
Yes,
existing?
Yes.
Okay, so now I've gone through where this equation comes from. It exists just like this one does. And what do I need to know to be able to use this one, the slope in any point?
Okay.
So what's the y piece of the point?
7.
7. What's the slope? 2/5. What's the x piece of the point?
1.
1.
That's all.
And that is an equation of the line.
Okay.
Now, watch. Can you guys understand that the y-intercept is probably gross? Here? Maybe you can't quite see it, but it's going to be gross. Is everybody cool with where we are right now? Again, if I know m and b, I use this the way we've always done. You guys all seem pretty cool with that. We've developed a new y equation form, right? Form of the line. It's this one. And now I don't have to know b. I could use any point that I want to. The x piece and the y piece go there and there, the same way that b would go there. But you can see why this equation is the way it is, based on what we did over there. All right. So now here, let me try to take this one step further. Is everybody cool with where we are now? I think we are. Can I solve this for y? This is where you guys are going to really love it. Right, we're going to have some fraction shit to deal with, right? You guys see that? What's going to have to happen on this side?
Multiply.
Yeah, 2/5 x minus 2/5. And then I have to try to get y by itself.
I'll be add 7.
Add 7. So this will be, LCD is obviously 5. Is that cool? So it'll be 35 minus 2, 33/5. Bam! So I can solve for y and put it into mx plus b form. So did I really want to try to figure out the y-intercept so I can use this? No. That y-intercept is a little gross, right? Thankfully, I have a form of an equation that I don't need the y-intercept to use. I can solve it and see how gross it is, but I don't have to use it in the first place. Do you guys get that? Maybe? Not? Maybe? So I want you to realize why it makes sense for us to try to develop a different form of this equation. Because this is only immediately useful if I know what b is. And I'm not always going to know what b is. All right. I like it. Yes?
Is the LCD in black?
Yeah, the LCD has to be 5, so I just multiplied by 5.
Okay.
And that's 35 minus 2. That's where the 33 came from. Cool.
Yeah, I just couldn't see what number was.
Oh yeah, I got the mystery liquid anyway.
It looked like a 1.
Oh, I see, okay. All right, maybe. Let's try another one.
Yes.
Yes.
Just
How about if I say this? We've done a problem like this before, just let's see if you guys can get this. Find the equation of the line that, I'm going to put the rest of the problem up there, but what two things do you need for the equation of a line? I need the slope and a point. So now we're better. Now we're more sophisticated. I don't have to have the y-intercept. I can actually do any point you give me, I can do it. If it's the y-intercept that kind of kicks ass, because then I don't have to use this long one, I can use the short one. Do you guys see that? If I know the y-intercept, kick ass, right? So of course Jeff won't give us the y-intercept here, because he's an asshole. Let's see. Is he going to give us a gross slope? Maybe. Let's see. Maybe I won't be so evil. So what have I not given you that I just said we need? Slope. Have I given you a way to find it? So watch this. I need two things. A point and the slope. Right? So if I were you, if I ever see a problem that says find the equation of the line that, stop reading, write down point and slope. So that you know you're going to focus on those two things. To figure. Once you get those two things, you throw them in, you get the answer, you're done. Do I have a point?
yes.
Sometimes I have a point. Today I do. I have two frickin' points. Which one do you want to use? You can use either one. Say again?
5 and negative 2.
5, negative 2, okay. To be honest, we're actually going to use 7, 6 later just to show you get the exact same equation. I like it. And now how do I figure out the slope?
6 minus negative 2.
Yeah, I got the equation right over there, right? So take a second and figure out what the slope is. Or several seconds. Nope. That's a 5 there, right? Okay.
4 2. My bad.
That's not 4. It's not 4.
6 minus 2.
No, that's not what the equation says. y2 minus y1. So 6 minus negative 2.
Oh.
Don't trust your brain. And I don't mean that. I mean that because our brain says there's a minus there, but the equation needs a minus also. So if I do the slope, it's going to be this y2 minus y minus that. Yes?
Yes.
I know very often you leave off the other one because you're like, there's already a negative. No, there's a minus in the equation, and that is minus. That's negative. So minus a negative over 7 minus 5. So again, if you want to, you can label these x1, y1, x2, y2. I want you to start working in the direction where you don't need that shit. The only reason the subscripts are really there is because you have to subtract in the same order. If I do this y minus that one, I have to do this x minus that one. Same order or else my sign is wrong. And what the hell do you get from all that? 8 over 2, which is 4. Yay! So go ahead and put the equation together. So somebody pick that point for me. Let's use that one. And you know the slope now. And it's not even a fraction. Shouldn't be too evil. What else came in here? Nada. Abigail. You're going to have the same issue right here, right? Y minus what?
-2.
Yeah. M x minus 5. You guys see that? What should make sense is when I'm using mx plus b, I just need to know what b is. Because it's a y-intercept, x is going to be 0, it doesn't show up. If x is 0, that's not there. Right? So if I have a point that's not the y-intercept, both parts have to show up. Neither one of them is 0. That's the part that's different for us. We're used to just putting a number in for b and being done with it. Here I've got to have both parts of it. Neither one is 0. So they're going to both show up. So here I got
Y plus 2.
y plus 2 equals
4x minus 20.
20. I like it. Subtract 2. 4x minus 22. Bam! That's the answer. How do I check it? You want to see how to check it? Don't put that point in because that's how you made it. Put that point in. It's got to work for the other point. So if I put a 7 in, what's 7 times 4? 28. Minus 22 is 6. Kick ass. See, the other point works. Maybe? All right, let's do it all over again, but use the other point instead. We won't use 5, -2. And this is where some people don't believe that it should come out to be the same equation. So I'm going to use the 0.76, and we already figured out the slope is 4. Is that cool? So I'm just going to do it again, but instead of picking the 0.5 -2, I'm going to pick the 0.76. Are you guys with me? Nobody? Okay. Well, we're all together in the same room. That's something. So then I have y minus the y piece, mx minus the x piece. So y minus 6, the y piece, equals m x minus the x piece. Do you see how that gets put together? So then y minus 6 equals 4x minus 28. If I add 6, what do I get?
-22.
-22. Same equation, of course it is. Because how many points work in that equation? How many points work in this equation?
Anything that's on the line.
Infinite number. So any of them should give me this equation. Any point this line goes through should give me this equation. That's why it doesn't matter which one I pick. So if I were you, I would try to maybe pick the one that doesn't have a negative. Even if I'm me, and I am currently me, I'm going to pick the one that doesn't have a negative because I know I'm a human being and we can make mistakes here easier if there's multiple negatives in a problem. You guys with me? So if I have a point where there's no negatives, shit, yeah, I'm using that one. Unless this is 5 -2 and that's 7763. Maybe I want, big ass numbers then. Another place a human can make a mistake. Anyway, sorry. you have a choice that you can make there. Which point to use. I like it. All right, let's try a different kind. Let's see. Or maybe I should go to the packet now. The packet's got all kinds of examples. So everybody's got this sucker now? Anybody else need this? We did most of the first part. We left off the last page. Ooh, that one's yummy. Try to do number 1 there. The slope of the point slope form of the line was slope negative 1/3 passing to the point. Real quick, do you see why we call this point slope? Right? Not point break. There's no Keanu Reeves, but point slope because that's the slope and this is a point. And we are very creative people as math people. So we said, let's call it point slope. So we understand you're doing a problem now, right? Number 1. Yes, the very last page. Point slope form was slope negative 1/3 passing through 1 negative 2. Do that. This one's kind of nice because there's no choice to make. There's only 1 point. It didn't say solve for y though, did it? Is that what you guys are doing? I don't know. The first step here, this is the only step. What goes in here? Y minus
Minus 2.
2, right?
Yes.
Oh, did I write down?
Yeah, you wrote it.
1 negative 2, okay. We try again.
Sorry, negative 2.
Yeah, so y minus negative 2, I'm with you. And of course, what goes here?
1
Negative 1/3?
X multiplied. Yeah, 1.
1,
Yes.
yeah. I mean, I really, really want you guys to understand where this equation came from. This equation just came from the difference in the y's divided by the difference in the x's. That's where it came from. We just played around with it and made it into an equation, like mx plus b, just bigger, so there was room for a whole point instead of just b. Okay? So now, if I know the slope in any point, I plug them in, I get the equation. I'm done. Thank you. So then you can really stop here for this problem, because it didn't say solve for y, did it? This form is called point slope. What's mx plus b called? Slope. What's the b again? Intercept. Slope intercept. I like it. So look at number 2. Try that one out. It does say to put it into slope intercept form, which means solve for y. So try out number 2.
Why are you going to continue with this one?
Say what?
Continue.
We're done with that one.
Done?
Yes, because the problem, what did it say? Put it in slope intercept form. That is slope intercept form.
Oh,
Yeah, I'm sorry, point slope.
I think we have to
Point
solve.
slope form. The one number 2 says, put it into slope intercept form, which is solve for y.
Solve.
Yeah.